Hello friends and neighbors, Super G here, also known as Mr. Gillespie. In this lecture video, we are going to talk about rearranging equations. I know it's been bothering all of you for a long time. How do you get a variable isolated? You've been thinking and thinking, it's kept you up nights. Well, I'm going to show you how. Let's take a very simple equation and rearrange it. For example, in physics, a very simple one is force equals ma. So force equals mass times acceleration. Now, sometimes we'll be given the force, or we can measure the mass or whatever, and we're going to want to know the acceleration of an object. Well, all we have to do is rearrange this equation so that A is by itself, acceleration is by itself. When you're rearranging equations, all you do is add, subtract, multiply, and divide to make your variable by itself. So this is a very simple one because all we have to do is divide both sides by m. The way I think of it is, I want to get a by itself, so I have to get rid of m. How can I get rid of m? Well, divide it by itself, and then it becomes 1 and factors out, and a will be by itself because it will be a times 1. Well, one thing about algebra, about math, is if you do something to one side of the equation, you have to do it to the other side of the equation to keep the equality going. So I have. And look what happens. This factors out, and I now have a equals f over m. A equals f over m. It's that simple. Now, there's all sorts of tricks and stuff, but if you just keep it simple like that, this is going to work out well for you. Let's try one where you also have to be doing some adding and subtracting. So, here's another physics one. VF equals VI plus AT. And let's just say I again want to know A. Well, try to remember this. When you're doing blank equations and you're trying to rearrange them and you're trying to get your variable by itself, first add and subtract to get it by itself. What I mean by this is I've got two terms here, AT and VI. Well, the first thing I do is get rid of the VI, and then AT will be by itself. Okay? Now, how do we get rid of VI? Well, we will subtract VI from both sides. So I'm going to say minus VI, and here I'll go minus VI. You understand that adding a negative VI is the same as subtracting it, right? So VI minus VI equals 0. Now we've got AT. And we've got VF plus a negative VI. Now, I'm going to divide both sides by T, because that, my friends, will factor out this T, as I did over there. We now have A by itself. So I can rewrite this so it's a little more palatable to the brain. We've got A equals, and I'm going to rewrite this to say VF minus VI all over T. Ta-da! Oh, that's the definition of acceleration right there. Very nice. So they get complicated, they get real complicated. And let's try one with a square in it, like a square distance. That would be good. Oh, let's see, I need to have a little more. Oh, why don't I just give myself a blank board? The wonders of the science room. So let's say I have something like this. Force of gravity equals a constant G times mass A times mass B, all divided by d squared, the distance between the two objects. So this is the gravitational attraction force. So, how would I get the distance between them isolated, all by itself? Well, the first thing you do in this sort of circumstance is to get it up on top. You don't want the thing you're looking for on the bottom. So you multiply both sides by d squared. That puts d squared on the top. It's on this side, but that's fine, because now these are factored out. Now, how do I get rid of the f of g so that d squared is by itself? Well, how about dividing both sides by fg? That will get rid of this. Now I've got d squared all by itself. How do I get the square away? Well, how do you get rid of a square? You square root it. So I'm going to square root both sides. And there, my friends, you have it. I'll rewrite it over here so it's more, again, palatable to the brain. We've got d. See, this square and the square root go away. They cancel each other out. So I've got d equals, and I've got the square root, the whole thing is square rooted, of g, m, a, and b, all divided by force of gravity. And there we are. It's not hard. Now, I tend to do it so that I don't have all these problems, all these different things happening. I'll show you what I mean. I'm going to redo this one, or any one, and instead of writing out the steps, I'm just going to do it to one side. I'll show you what I mean. Here, we'll do this one again. VF equals VI plus AT. Now, I'm going to get T by itself. The first thing I do is I say, I'm going to put this in the middle one. Try it again. I'm going to try it again. VF, I'm going to leave some space there, equals VI plus AT. Okay? And I'm saying I want T by itself. So what's the first thing you do? Add and subtract to get rid of this other term and just have AT by itself. And then you can divide by A to get T by itself. So the first thing I do is subtract VI from both sides. Now, this is my point. I'm not writing minus VI on this side. I know that it's just going away. So I just write it on that side. It makes it a lot cleaner. Now I've got VF minus VI equals AT. Divide both sides by A. And I'm done. It's just a lot cleaner this way. I don't have to write divide by A here. I know that it just got factored out, so I just get rid of the A. Now I have T equals VF minus VI over A. It's that easy. It starts to become easier and easier, so you need to practice. Thank you.